Hello everyone and welcome to this video. My name is Kalina and today I'm going to take you through the solution to question 9 from this Leaving Cert higher level paper. Now this question is based on trigonometry and let's get into it. So in this question we're told that Oscar is taking measurements and using trigonometry to work out angles, distances and areas. And we're told that firstly Oscar takes the measurements of two adjacent triangular fields. So field A or field 1 and field 2, and we're given a diagram. So it just gives us a bit of information about the field. It tells us that B lies on the line AD, so B is here. And then it just gives us some measurements. So it tells us that AB is 30, as we can see here. BD is 10 meters, AC is 35 meters, and the angle CAD is 50 meters. And we're told that to note that the angle ABC is not a right angle. So this angle here is not a right angle. So now let's go on to question A. So question A asks us to find the area of field 1 and then hence, and the word hence in maths basically means using the information that you've just found, find the area of field 2. And we're asked to give each answer correct to the nearest meter squared. So I'm going to go to my log tables and find the formula that I can use to find the area of a triangle. So here on page 16, we can find the chapter based on trigonometry of the triangle, and we're going to use this formula for the area, and that is half AB sine C. And just to notice here that C is a capital C, and that is the angle across from small c. But in our question, we actually don't know what small c is, but that's okay because we don't need to use it in this formula. So I'm just going to write out the formula. So we have half AB sine C. So A is 35 here, B is 30, and the sine of C, okay, so I'll just write C is equal to 50, so the sine of C is just the sine of 50. So let me fill this out to find the area of field 1. So I'll write field 1 is equal to half multiplied by 35 multiplied by 30 multiplied by the sine of 50. And let's pop this into the calculator and see what we get. So I'm going to put in half multiplied by 35 multiplied by 30 multiplied by the sine of 50. And that gives us 402.17. And that's in meters squared, but it asks us to give it correct to the nearest meter squared. So that is 402 meters squared. So now, how are we going to work out the area of field 2 by using our answer for field 1? Let's have a look at the diagram again. Now, you can see here that you can use the same formula that we've just used to find field 1 to find the whole of field 1 and field 2. So what we're going to do is find the area of both fields and then take away the area of field 1 to find the area of field 2. So let's draw a diagram representing what we want to look for, okay? So here is both fields. We know that this length up the side here is 35. We'll remember that this here divides field 1 and field 2. This was 30 and this was 10. So this altogether is 40 meters, and this is still 50 here. So we're going to use the same formula. So I'm going to write both fields. It's going to be half multiplied by A is still 35. Now B is 40, and C is still 50 degrees. So half 35 multiplied by 40 multiplied by the sine of 15, that will give us the area of both fields. So I'm just going to go back along my formula here and change the 30 to a 40. Because everything else is the same here. And we get an answer of 536 meters squared to the nearest meter squared. So now field 1 is going to be both fields minus, or field 2 is going to be both fields minus field 1. So I'm going to take away 402 here and we're left with 134 meters squared. So field 2 is 134 meters squared. So let's just fill this out in the boxes they've given us. The area of field 1 was 402 meters squared, and the area of field 2 was 134 meters squared. And for this question, for getting those two answers, you'll get yourself 10 marks. So now let's move on to question B, which asks us to find the length of the perimeter of field 1 correct to the nearest meter. So let's scroll up and have a look at the diagram again. So we're looking for 35 plus 30. We have those two values. All we're looking for here is CB. So what I'm going to use is I'm going to use the cosine rule to find C and B. Because we have A, we have B, we're looking for C, and this here is the sine of C, which we know. So let's use the cosine rule to help us here. So I'm just going to draw out what we have. So this is 50 degrees, 35 meters, 30 meters, and I'll leave a question mark here. So if you go to the log tables and find the cosine rule, and that is a squared is equal to b squared plus c squared minus 2bc cos of a. So we're going to call this a here because we have the cos of a. So a is what we're looking for, b is 35, c is 30, and the cos of a is equal to the cos of 50. So let's fill this out and find a. So a squared is equal to 35 squared plus 30 squared minus 2bc, so 235 multiplied by 30 cos of 50. So now let's work out the right hand side. So a squared is equal to, and I'm going to put that into the calculator. So that's 35 squared plus 30 squared minus 2 by 35 by 30 by the cos of 50 degrees. So that is 775.15. So now to find a, we're going to find the square root of both sides. So the square root of a squared is just a, is equal to the square root of 775.15. And let's put this into the calculator. And that gives us an answer of 27.84 meters. Okay, now be careful to realize that you're not finished the questionnaire because we're not just asked to find the length of, I think it's BC here, you're asked to find the perimeter of field 1. So you need to add, and you're asked to give your answer correct to the nearest meter, so we can write A as 28 meters. So now we need to add 28 meters to 30 meters to 35 meters. So the perimeter is equal to 35 plus 30 plus 28, and let's add those all up. And that gives us a perimeter of 93 meters. And this is our final answer for that question. And for this question, you're going to get yourself 10 marks. So now moving on to question C. We're told that Oscar's also watching an airplane, P, fly directly over his head. He's standing at the point O in the diagrams below. So here's Oscar. The x-axis is the horizontal ground and the y-axis runs vertically above or vertically up from Oscar. The airplane P is flying at a constant height of 10 kilometers above the ground. So that's shown here. So C tells us that sound travels at a speed of roughly 343 meters per second in air. And question part 1 asks us, as the airplane flies, its engine makes noise, but it takes some time for this sound to reach Oscar. So use the information in diagram 1 to show that it takes 41 seconds for the sound the airplane makes at P1 to reach Oscar, correct to the nearest second. So we're told the speed of sound through air. So the speed is equal to 343 meters per second. We don't know the distance that the sound has to travel. That's what we're looking for. We're looking from the distance from P1 here to Oscar, because P1 is where the airplane is making the sound and O is where Oscar is standing and hearing it. We're asked to show that it takes 41 seconds. Okay, so we know the time is 41 seconds, but we actually have to prove this. So what we need to do is we need to find the distance. So I'm just going to draw out the triangle that's going to help us with this. And that is this triangle here. So that is 45 degrees, We know this is a right angle. So this must also be 45 degrees, because if that is 90 degrees and that is 45 degrees, this must be 45 degrees because there's 180 degrees in a triangle. This is 10 kilometers. This must also be 10 kilometers because we can see that it is actually an isosceles triangle here. So all we need to do now is work out this distance here. So we'll call that x. So x squared is equal to 10 squared plus 10 squared. So x is equal to the square root of 100 plus 100. So that's 200. So x is equal to, and I'll pop this into my calculator, 10 root 2, and that's kilometers. But I'm going to want to find this in meters because we can see that the speed is in meters per second. So 10 root 2 kilometers in meters. So 10 root 2 kilometers is 14.14 kilometers. So I'm going to multiply that by 1,000 to find it in meters because there's 1,000 meters in a kilometer. So that's 14,142.14 meters. So now let's prove that it takes 41 seconds for the sound the airplane makes at P1 to reach Oscar. So I'm going to use my distance, speed, and time triangle. So we have distance, speed, and time. So we're looking for time. So we cover time and we're left with distance over speed. So the distance here we know is 14,142.14 meters. I'm just going to leave it in meters here. Divided by the speed, and the speed is 343 meters per second, and we should come up with an answer of 41 seconds here. So divided by 343 meters, and alas, we're left with 41 seconds. So we have proved that it takes 41 seconds for the sound the airplane makes at P1 to reach Oscar. So I'm going to draw a nice neat box around here, especially because we're kind of caught for space here, just to make it look more neat. And then for this answer, you're going to get a total of 5 marks. For the second part of this question, question C part 2, we're also going to use our distance, speed, and time triangle. We're told that the airplane P is flying at a constant speed of 255 meters per second. By the time Oscar hears the sound the airplane made at point P1, the airplane has flown onto the point P2. We're asked to work out the size of the angle, theta, in diagram 2, correct to 1 decimal place. So the first thing we're going to do is we're going to look up at the diagram here. So we know that the plane is traveling at 255 meters per second, and we're looking in diagram 2 here. So we're saying that when Oscar hears the sound from plane 1, the plane is at the point P2. So we're asked to find this angle here. So how are we going to find that? We know the speed that the plane is traveling at. The plane is traveling at 255 meters per second. And we know that the time it takes to get from here to here is 41 seconds, because it's the same time that it takes the sound here to travel to Oscar. So we know it's 41 seconds. So we can work out the distance here, and then let's use that to find the angle theta. So let's first of all work out the distance. So here's P1, here's P2. What's the distance? We'll call it D. We know the speed is 255 meters per second, and the time is 41 seconds. So here's our distance, speed, time triangle. So we're looking for distance, so we multiply speed by time. So the distance is equal to 255 multiplied by 41, and we're going to find the distance in meters. And that's 10,455 meters. So now we have this triangle. We're looking for this angle here. We know that this is 45 degrees from diagram 1. We know this distance here down the side is 14,142 meters from the last question. So now, how are we going to find this angle here? We know that this is a right angle as well, and we know that from here to here was 10 kilometers, so 10,000 meters. So I'm going to take out the triangle on the right. So here's theta. This is 455 meters, okay, because I'm after taking out the 10,000 kilometers. And this is a right angle. We also know that this is 10,000 meters because we know that the plane is flying at a constant height of 10 kilometers above the ground, and 10 kilometers is 10,000 meters. So now we can see that we can use our sine, cos, tan rules to figure out what theta is. So here, what do we have? We have the angle opposite we have the side opposite the angle, and we have the side adjacent to the angle. So we're going to use tan, because tan of theta is equal to the opposite over the adjacent. So tan of theta is equal to 455 meters all over 10,000 meters. So theta is equal to the tan inverse of 455 over 10,000. And let's put this into our calculator to calculate theta. And that gives us an answer of 2.6 degrees. And that is correct to one decimal place as we're asked. So I'm going to put a box around this. That's our final answer. They've asked us to calculate the size of the angle marked theta in diagram 2. And so for this answer, we're going to get 10 marks. Now in question D, we're still dealing with a very similar diagram. We're told that P3 and P4 are two other points on the flight path of the airplane P. So they're other points that the airplane flies through when it's flying above Oscar 10,000 meters above him. By the time Oscar hears the sound of the airplane made at point P3, the airplane has flown on to the point P4, as shown in the diagram below. P3 and P4 are both a distance of d kilometers from the y-axis. And we're asked to show why the following equation holds. And it's this equation here. The root of 100 plus d squared all over 0.343 is equal to 2d over 0.255. So let's see what we're told. We're told that by the time Oscar hears the sound the airplane made at point P3. Now, you'll remember that we're told the speed of sound through air earlier up in the question. So let me just find that. So sound travels at a speed of 343 meters per second in air. So I'm going to write that down there. So sound through air, 343 meters per second. So the sound is traveling here from P3 to Oscar at 343 meters per second. Now, the sound is traveling, or the airplane is traveling at, and we're given the speed for that as well. I think it was 255 meters per second. So that is the speed of both the sound and the plane. But we're told that the time that it takes for the sound to go from P3 to Oscar is the same time that it takes to get from P3 to P4. So what's the distance between P3 and P4? So distance from P3 to P4 is 2d. The speed from P3 to P4 is 255 meters per second. Now, let's work out the distance between P3 and 0, or P3 and O, which is where Oscar's standing. So we know that this is 10 kilometers. I'm just going to change this from 255 meters per second to 0.255 kilometers per second, because I can see that they're using this in the question. So the distance from P3 to Oscar, okay, I'm going to use Pythagoras here. So we have d 10, and this is what we're looking for. This is the distance we're looking for. So that is, so question mark squared is equal to d squared plus 10 squared. So question mark is equal to square root of 100, which is 10 squared, plus d squared. And the speed that it's traveling is 343 meters per second, which is 0.343 kilometers per second. So speed is equal to 0.343 kilometers per second. Okay, so to fully explain this now, all you have to say is that basically the time taken for the sound to go from P3 to 0 is the exact same as the time taken for the sound to go from P3 to P4, or for the plane to go from P3 to P4. Okay, so I'll just say here, time taken for sound to go from P3 to Oscar is equal to time taken for plane to go from P3 to P4. Because if you were writing out the time here, time in this instance is distance divided by speed. So you can see here that this is the time taken for the plane to go from P3 to P4. So that's 2d divided by the speed, which is 0.255 kilometers per second. And this here is the time taken for the sound to travel from P3 to Oscar, because these are the same time. So we have to let them equal to each other. So you can see the distance on top here, which is root 100 plus 2d, divided by the speed, which is 0.343 meters per second. So it's not giving you very much space here, but it's actually not it's not requiring too much calculations. They've done the calculations for you. All they want you to understand in this question is that the following equation holds because the time taken for the sound to go from the point P3 to Oscar is the same as the time taken for the plane to fly from P3 to P4. And for this understanding, you're going to get 5 marks. So now the last part of this question actually involves a bit of algebra. It just wants us to solve the above equation to find the value of d correct to 1 decimal place. So let's just write out the equation from above. So we had 100 plus d squared all over 0.343 is equal to 2d divided by 0.255. So the first thing I'm going to do is I'm going to cross multiply. So I'm going to have 0.343 multiplied by 2d and let that equal to 0.255 multiplied by the square root of 100 plus d squared. Now, we have a square root here. So what I'm going to do is I'm going to square both sides. But before I do that, I'm going to multiply 0.343 by 2d. So I'm just going to multiply 0.343 by 2. So we are left with 0.686d. And that's equal to 2.255 root 100 plus 2d. So now let's square both sides. So the square root of 0.686 is equal to 0.4706. The square of 0.255 will now work out as well. And that is 0.065. And then when we square a square root, we're just left with what's inside the square root, 100 plus d squared. Sorry, this should be d squared here. I just forgot to put that in. So we have 0.4706d squared is equal to 0.065 multiplied by 100 plus d squared. So I'm going to multiply that out. So I have 0.4706 d squared, and that is equal to 0.065 multiplied by 100, which will give us 6.5 plus 0.065 d squared. So I'm going to put the d squares on one side. So I'm going to bring this over and it's going to become minus. So I'm going to have 0.4706 take away 0.065. So I am left with 0.4056 d squared, and that's equal to 6.5. So I'm going to get 6.5 divided by 0.4056 So then I'm left with d squared is equal to the result of that. So 6.5 divided by 0.4056. And we get an answer of 16. So let's square both sides. D is equal to the square root of 16, which is 4. So that is our final answer. D is equal to 4, and you're going to get 10 marks for that. One thing that I think was put in probably to put you off here, it asks to put the value of D correct to one decimal place. We can see here that it's 16.02. So to one decimal place, it's 16.0, which is just 16. Okay, so don't be thrown off thinking that you have got the wrong answer because of this. So this is all for this question, guys. Thank you very much for watching. I hope that it might have cleared up anything that you were stuck with on this question. I'll see you all in the next video.